Hi students. So today we'll be doing a very interesting character of refraction. Okay? Ekdom easy, dekho, ekdom soja. We'll be doing two of the characters of refraction. Okay? The first one is the real and apparent depth. The first one is the real and apparent depth. The second one is your total internal reflection. So these two topics will be covered in today's class. Okay, so let's begin the class. Okay, the first is what is real and apparent depth. Very easy. See, let me take an example and you will understand it better. Say, when you are a child, you used to visit many fairs, isn't it? We can on a game asilo যেখানে at a particular there was a particular say bucket. In that bucket water was placed and a coin was there in the bucket. Okay, and we are given certain stones. This bucket is full of water. We are given certain stones and we have to hit the particular coin by just looking above the water itself. ঠিক আছে, bucket মধ্যে জল থাকতো, we have to drop the stone and we have to hit the particular coin. Now interestingly you will see that majority of the times you will not be able to touch the particular coin with the help of the stone. পারতেই না. Now why is that? যে আমরা এখানে particular এই কয়েনটারে আমরা এখানে টাচ করতে পারি না? Because দেখো এটা এক্সপ্লেইন করতেছি. দেখো, because see if the water was not there, see this is the water level. See if the water was not there, say here is the stone. Understood? koi ase stone ta ei je stone ta. So here there was the stone and when there was no water, say you are looking at the stone now and no water is here. Okay, no water is here, and the light that falls on the falls on the coin, this light is reflected and it reaches to your eyes. समझ में आया? When there was no water, what happens? Light from outside falls on the coin and this light is reflected to your eyes, and then only your eyes is able to see the stone here. আমি লাস্ট ক্লাসে কইছিলাম how do we see colors and how do we see a particular object? When light from outside sources falls on that object and then return to our eyes, then only we'll see the object. So when there was no water in the particular bucket, the light from outside falls on the coin and the light is reflected back to our eyes and we are able to see it. But now as I place the water now, what happened? You see, at the midpoint of the two surfaces, here there is air, isn't it? And here it is water. Initially there was air all over it, but now as I poured water, so there is a division, isn't it? Here it is air and here it is water. And we know whenever a certain medium is introduced, this medium, it will have a refractive index. Water have a refractive index of 1.5 and air have a refractive index of say 1. So refractive index of two different mediums will never be the same. And if the refractive index is not same between two mediums, what happens? What is the particular phenomenon that happens in light? কি আছিল? Refraction. ব্যাপারটা বুঝা গেছে? Refraction happens if there are two different medium. Okay, refraction happen. Now due to refraction what will happen? You see, due to refraction what will happen? Due to refraction, the light which was initially coming in this particular straight line, now it will not come in the straight line and it will be reflected away from the normal. If I draw a normal here, it will be reflected away from the normal because air is a lighter medium. It will be reflected away from the normal. Now in order to see the particular coin, you have to see from here, isn't it? I have to see from here the particular coin. And where will our brain process this image? ব্রেন কই রাখবো? ব্রেন কিন্তু যে সেম জায়গাতে দেখতো না। আমরার ব্রেন কি করে? Our brain it extends the light that is coming to our eyes. It extends the light that is coming to our eyes, and if I draw a straight line from this coin, the coin will appear here. It will appear raised. Understood? It will not appear as it is. It will appear raised from its usual level. That is the only reason যে সময় আমরা কাছে ফেয়ারের মধ্যে মেলাতে, হ্যাঁ, in Bengali we used to tell it mela, আর ইংলিশে it is fair. Okay, in a fair, whenever this particular sport is played, okay, you will not be able to hit that particular stone, a particular coin with that stone, because the image always appear to be raised, or the image always appear to be a bit in a different place. It will appear in a different place than it is actually is. Okay, now arekta example দিতাছি. Say for example, whenever you visit a swimming pool, okay, whenever you visit a swimming pool, say you are learning how to swim. So at first when you will be visiting the swimming pool, you will see that the swimming pool is not that shallow as it appears. Understood? Actually the swimming pool will have a great depth, but তুমি যে সময় যাবে এখানে, the surface of the swimming pool will appear to be raised. You will just put your leg there, and what will happen? You will fall in the swimming pool itself. Understood? Okay, understood. So this is also a phenomenon of real and apparent depth, because in a particular medium, say example water, the object always appear to be in a different place due to refraction, because there is a division between the mediums. Now we need a particular formula. We need a formula to find actually how much is the shift that is happening here between the real and the apparent image. This is known as the apparent image. This is known as the apparent image, and this is known as the real image. So between the real and the apparent image, how much shift is there? So we'll be doing that now. See it closely. Let me rub this diagram. Okay. So now you see, so let us zoom in the image. Okay, আচ্ছা, zoom করে যদি দেখো so this is the water level. Say here is the coin. Okay, so initially what happened, light goes and it travels straight, but now due to refraction it travels away from the normal. Okay, this is the normal. Understood? So now if I want to see the image, it will appear here. Okay, it will appear in this particular point. So I have to find this displacement, how much shift or how much displacement is seen in the images. Now you see, initially this was the incident angle, isn't it? This is the normal and this is the ray of light. So this is the incident angle. Okay, from here it came. Okay, this is the incident angle. So alternatively this is also the incident angle. Now when it went outside, okay, when it went outside, this is the normal, so this will be the refracted angle. This whole angle will be the refracted angle. Now if you see closely, this is a straight line, isn't it? This is a straight line. So this refracted angle and this one, this is a corresponding angle, isn't it? This particular line and this particular line, say this is AB and say this is CD. AB and CD, if you closely see, AB and CD, if you closely see, these two lines are what? They are parallel to each other, because both of them are 90 degrees. They are parallel to each other. So this angle and this angle will be corresponding in nature. They will be corresponding in nature. Understood? So now, what I'll do, I'll just mark the points A, B. Let this point be E. Okay. So now, from triangle ABE, if I find the value of sine I, see the alternative angle of incident angle, okay, the incident angle, alternative angle, if I take this angle, so from this particular triangle, if I want to find the value of sine I, how much it will be? See, in order to make it easier, you can draw a small triangle here, A, B and E. Okay, जब भी कोई problem करो, easy करने का सोचना, ठीक है? Always. Now you see, here it is I, and this is your 90 degree. So sin I means what? Perpendicular divided by hypotenuse. The perpendicular here is AE and the hypotenuse here is BE. Similarly, let this be point F. From triangle AFE, if I want to find sin R, then it will be, see, AE by FE. See, AE is the perpendicular and FE is the hypotenuse. Understood up to this much? Now say I want to find how much refractive index is there. Now, in the last class also I have shown that always you should remember we use Snell's law, isn't it? We use Snell's law to find the refractive index. আচ্ছা ঠিক আছে, তো আমরা Snell's law দিয়ে সবসময় কি করি, আমরা refractive index বাইর করি. But you should always remember that using that formula will give you the refractive index of the medium where the light is going. Always remember, it gives the refractive index of the medium where the light is going. See, the light is, in this case, the light is going into air medium, isn't it? So the mu that you'll be finding will be of that of air with respect to water. That means the light is traveling from water to air. Understood? Always you should remember, using Snell's law, if you find the refractive index, that will give me the refractive index of the medium in which the light is actually going. So now it will be sin I by sin R, isn't it? Snell's law. Okay, mu equals to sin I by sin R. If I use this formula, see, in these two formulas, A is common, isn't it? So the final answer must appear like this. না বুঝলে একবার কইরা দেখো, এখানে জাস্ট ভ্যালু প্লেস করো, কাটাকাটি করো, then you will get the answer. After cutting the values, you will get the answer here. Now, last day we also did a particular law, that is reversibility of light. Anyone who have missed the class, you can see the last day's video. We have particularly done this law, okay, reversibility of light. It states that what? It states that light, when traveling from one medium to another, if it follows a path, while returning back, it will also follow that path, provided it is reflected back. That means provided it starts from the same point itself. Okay, at the point where it ends, it should start from that point also. Okay. Now, by reversibility of light, there was a particular formula that I gained, that mu of air with respect to water will be 1 by mu of water with respect to air. So here I can write equals to Fe by Be. If I reverse the formula, I will get what? দেখো, will this value come? See closely, will this value come? Okay, now you see, now it is very interesting. So here, if I rub this particular part, দেখো, finally আমরা কি ফর্মুলা পাইতাছি এখান থেকে? Mu of A with water equals to, now look closely, very interesting thing here. Now look closely. BE, where is BE? This point is B and this point is C. Now remember, this whole phenomenon is the basic rule of refraction. Okay, this whole phenomenon happens because of refraction, and refraction happens in where? In light. And light, when travels, see, these angles, it seems to be very big, isn't it? In diagram it is very big, but in practicality these angles are very, very small. So if these angles are very small, then that means this particular angle, if this is 40 degree, say for example, now if I reduce this angle to 10 degrees, say, then what will happen? I have to move this line here, isn't it? Understood? See, initially I have taken an example of 40 degrees, so this is the very big angle. The line hypotenuse should be here. In order to make it 10 degree, in order to reduce this particular angle, so the point here have to move here, isn't it? It have to reduce. As I told, it is a phenomenon of light. The angles will be very, very small. And if you want to make this much small angle, then this E point have to move more forward. And if I move it more forward, it will ultimately collapse with A, isn't it? If I move this E more forward, it will obviously collapse with A. So that means in place of BE, I can, in place of BE, I can easily write AB. If you understood this part, see closely. Here also FE, here was the refraction angle. Now if I reduce this refraction angle, I have to reduce the hypotenuse length, isn't it? So ultimately, by reducing this particular angle to minimum, to negligible values, this particular line will ultimately meet with AF. That means it will be approximately equal to AF. Now you see, AB, this AB was the what? It was the real depth. The real object was here, and this is the real depth, isn't it? So this will be the real depth, and this particular line AF, this is the apparent image. Now this is the last image. This is the false image that I see. False. The meaning of false is apparent here. Okay. The false image that I see, that means the apparent image that I see here. This is the apparent depth. This is the apparent depth. So the value of mu of water equals to real depth by apparent depth. This is a particular formula which you will need in this particular chapter. Very easy formula. See, mu equals to real depth divided by apparent depth. But my ultimate goal is to find the shift. See, initially in the problem itself I told my ultimate goal should be to find the shift here. Understood? So in order to find the shift, see what we can do. This shift is equal to AB minus AF, isn't it? AB is the real depth and AF is the apparent depth. Understood? Now from this formula, what I can write, see, in place of apparent depth, if I move this apparent depth here and if I move this mu here, I can write R by mu, isn't it? R by mu of water. So ultimate result will be shift equals to, if I take real depth as common, it will be 1 minus 1 by mu of water with respect to air. Understood? So this is a very, very important formula to understand why an object appears a bit raised in water, say in a swimming pool, or if you drop a stick inside water, it will always appear to be bent. But you can do an example here. You can do it practically now also. Take a pencil, take a glass of water and gently drop that pencil into, hold that pencil and gently drop it into the glass of water. If you look through the glass, you will see that the starting of the pencil will appear a bit bent from the usual path. Understood? So this is known as the phenomenon of refraction. This is also due to the phenomenon of refraction. Understood? So now from this formula I can easily find that this shift, this particular shift in the image is actually depends on what factors. From this formula I can easily find. Now you see, in this formula you have your real depth, you have the mu, that means your refractive index. Now if I increase the real depth, now what is the real depth actually? If you see that image, if you rewind back and see the image, actually the real depth is nothing else but the thickness of the layer. Okay, the thickness of the water layer, but thickness of the glass medium, anything you can take. Okay, any medium you take, that thickness is actually the real depth. And as I can see from the formula, this shift and real depth is directly proportional, isn't it? It is directly proportional. So shift will be directly proportional to the thickness of the medium in which the object is placed. Always remember, medium in which the object is placed. Next, if you see closely, shift is proportional to, see, there is your mu is. Here there is your mu. That means if you increase the value of mu, see closely, if you increase the value of mu, if you increase the refractive index, okay, if you increase the refractive index, this whole value, this is 1 by refractive index, this value will obviously decrease. See, denominator, if it increases, the whole value will decrease. And from 1, if I subtract that value, the answer will come a bit less than in the case where the value of mu is less. See, let me take an example. Say, in a case, there the mu's value is, say, 0.5. So if I apply this formula, shift equals to R 1 minus 1 by 0.5, it will give me 2. then there will be a negative result, isn't it? Yeah. So let me take an example of say 1.5. So now I'll get a positive result. Obviously पहले वाले में नहीं मिला था, अभी मिलेगा. Okay, अभी मिलेगा, सब कुछ मिलेगा. देखो सब कुछ मिलेगा. 10 by 15 will give me 2 by 3, 3 into 1 by 3. Okay, so the answer will be r by 3. But see, the answer here is r by 3. But say in another case, I have taken the mu's value to be a bit greater. Okay, more than 1.5. That is, say there the value of mu is 3. So what will be the shift here? R into 1 by this one will give me 2 by 3. Understood? That means more the value of mu, more will be the result. Understood? So shift and refractive index will be directly proportional. Shift and mu or shift and refractive index is directly proportional. More the refractive index or more the value of mu, more will be the value of shift in the image. Last but not the least, this shift also depends on the wavelength of light. Okay, the wavelength of light. Now this is a very common thing. I have told that very times, starting from lateral displacement, then your dispersion, then your deviation angle. Okay, now here your real and apparent depth. All the cases, this particular shift or lateral displacement or deviation angle is always inversely related to the wavelength of light. More the wavelength of light, lesser will be the shift. More the wavelength of light, lesser will be the shift. Because more the wavelength, the light can travel more freely. Okay, like in the case of red light, it doesn't bend that much because its wavelength is very, very large. Okay, as compared to blue and violet, the wavelength of red light is very large. So it does not bend that much. So its shift or its lateral displacement, in the previous case, its lateral displacement will always be inversely proportional to the wavelength. Understood? So these three cases are the factors that determine how much shift in the real and apparent image will be showing. Okay. So now beginning with the next part, that is your total internal reflection. Okay, so what is actually total internal reflection? To understand that part, what I'll be doing, I'll be taking an example here, okay? A very basic example, you will understand it, okay? Don't worry. Say the previous example I am taking. Say there is a bucket of water here. Or say this is a glass slab, okay? I just love glass slab, okay? Glass slab usually helps us to understand a lot of phenomena in physics, okay? So don't ignore a glass slab, okay? So how to understand this particular total internal reflection? Okay, let me write here, total internal reflection. Now what is it actually? Say if an object is kept here, or say a laser light is kept here, okay, a yellow laser light is kept here, and the laser light, it is coming in this way. Okay, here is the point of incidence and this is the incident line, okay, or incident light. So this is the normal, there is air and it is glass. What will happen when the light will escape into air? It usually bends away from the normal. That you all know. It usually bends away from the normal. For example, say if the incident angle here is your 30 degree and the refracted angle here, it will be more, isn't it? It will be say 45 degree. Say for example it is 45 degree. Now, so another case, say this incident angle here, it is 30 degree. What I did, I bent the light a bit more. From its initial angle, I have bent the light a bit more. In the same case itself, I bend it a bit more. Say this light, now it is, say the incident angle is 45 degree. Say initially incident angle was 30 degree and the refracted angle was 45. Okay, so prothome 30 and the refracted angle was 45. But now the initial angle is, or the incident angle is 45 degree. So what do you think? What will be the refracted angle? More than the previous case or less? এটা কি বেশি হইব না কম হইব আগের থেকে? দেখো आगे incident angle 30 আছিল and it was moving outside, so it is greater 45 degree. Now I have increased this incident angle more, so the refracted angle will be what? More or less? It will always be more. It's moving away, isn't it? So it should always be more than 40 with this initial angle. Okay, so this particular angle, say for example, now it is say 75 degree. Say for example, this refracted angle is now 75 degree. Now if I continue this step, further, see, पहली बार में कितना था 45, फिर ये हुआ 75, फिर मैंने अगर ये इंसिडेंट एंगल बढ़ा दिया फिर से, ओके, इफ आई इंक्रीज दिस इंसिडेंट एंगल मोर, देन अल्टीमेटली एक ऐसा सिचुएशन आ जाएगा ना जब ये पर्टिकुलर रिफ्रैक्टेड लाइट will be just 90 degree to the surface. See, it became 75. Then if I increase it more, it will become 80. Then if I increase more, it will become 85. Then 90. Okay. So when it becomes 90, see here it is. Say I don't know what is the incident angle here, and the refracted angle here is 90 degree. So whenever the refracted angle becomes 90 degree, that means the light is retracing the surface. Retracing means, okay. Retracing means the light is going just on the lining of the surface. Okay, if the light goes just on the lining of the surface, or the light retraces the surface, then this incident angle is known as the critical angle. This is very, very important. This critical angle is very, very important. Always remember, this is the main reason why this particular phenomenon occurs. Because at a particular angle that is known as critical angle, the refracted angle appears to be 90 degree. और ये वाला जो चीज है ना critical angle, इतना इजी, मतलब इसका कोई phenomenon नहीं है, ऐसा नहीं हो सकता, इसका बहुत सारा phenomenon है. For example, if you take a test tube and you bring in direct sunlight, sometime you will see at a particular angle this test tube starts silvery, isn't it? The surface of the test tube starts a bit glittering. It appears a bit silvery. Okay, understood? So ये silvery क्यों appear होता है? Because of the fact that at that particular incident angle, the light is actually retracing the surface. At that particular incident angle, the light is actually retracing the surface. जब भी light surface पे retrace होता है, वो surface सिल्वरी अपियर होता है. बार बार कर रहा हूं, टर्म को याद रखना, टर्म में ध्यान देना. सिल्वरी अपियरेंस होता है, शाइन नहीं करता है, सिल्वरी अपियरेंस होता है. शाइन करने का मतलब और एक चीज हो जाएगा, वो मैं बाद में समझाऊंगा. ऑलवेज रिमेंबर, इफ द सरफेस अपियर्स सिल्वरी, दैट मीन्स एक्चुअली द लाइट इज फॉलिंग एट द क्रिटिकल एंगल. बट नाउ a situation arises. Say some of you must be thinking, what happens if this critical angle is, if the incident angle is greater than critical angle? No, very good. Okay, like this thinking should be appreciated. Okay, always remember, say if this particular incident angle is greater than critical angle. Now this incident angle is greater than critical angle. At critical angle, the light was 90 degree. The light reflected was 90 degree. So more than critical angle, it should come inside, isn't it? It should come into the glass surface itself. That means instead of having a full refraction, it is actually showing a type of reflection. Okay, it is coming into the same medium. Okay, the term reflection will be used now. But this is not a normal case of reflection. Okay, this is not a normal case of reflection. So इसको directly हम reflection नहीं बोल सकते. This is a particular phenomenon of refraction where reflection is seen. So this particular phenomenon is known as total internal reflection. यहाँ पर भी ये दो एंगल सेम होगा, रिफ्लेक्शन का सब लॉ यहाँ पर अप्लाई होगा. ठीक है, रिफ्लेक्शन का सब लॉ यहाँ पर अप्लाई होगा. But this is not a total case of reflection. This is a particular phenomenon of refraction. So this name is used. Now what you have to know, we have to know that this particular phenomenon, what does it actually do into a particular surface or into a particular medium. देखो एक एग्जांपल देता हूँ. डायमंड देखा है कोई? हीरा, डायमंड, हाँ, डायमंड. So whenever you buy a diamond necklace, or say you have bought a diamond ring, okay, you will see in dim light also, this diamond ring will always glow. It will glow. So whenever any surface shows the phenomenon of glowing, this is due to total internal reflection. This is due to total reflection. समझना है कैसे? देखो देखो एक्चुअली होता क्या है ना, जब हम डायमंड को डिराइव करते हैं, ओके, जब डायमंड को हम डिराइव करते हैं, कहां से डिराइव करते हैं? माइंड से, ओके, माइंड से डिराइव करोगे तो दैट डायमंड एक्चुअली इट डजंट ग्लो एट ऑल, ओके। जब माइंड से डिराइव करते हैं ना, इन इट्स रॉ फॉर्म इट डज नॉट ग्लो, इट अपीयर्स लाइक ए नॉर्मल व्हाइट कलर, व्हाइट और कलरलेस रॉक ओनली. So in order to glow it, what we do, we cut the diamond into many shapes, and special shape is what? Tetrahedral. Okay, this is the most loved shape, tetrahedral. Okay, so in this type of structure, what happens? You see, diamond means in a diamond ring or a diamond necklace, tetrahedral shape. What does it do? Whenever light enters in this particular diamond crystal, as it enters into the diamond, say diamond, its mu is 2.4. Refractive index is too much. Okay, and do we know more the refractive index, it will bend the light more. Instead of going straight, it will be bending the light in a huge reflection angle. Okay, so as it strikes here, this is the normal. So the angle it made, how much will be the angle? Just guess. Say, I think many of you guessed as 30 degree. Okay, let it be 30 degree. Do you know how much is the critical angle of diamond? How much is the critical angle of diamond? Do you know? It is 24 degree. That much less is the critical angle of diamond. That means this light, this incident angle is obviously more than 24 degrees incident. And as I explained earlier, if incident angle is greater than critical angle, this light will not come out of the surface, it will be reflected back as in total internal reflection. As it strikes this surface, here also it makes an angle that will be obviously greater than 24, because 24 is a very small angle. Okay, so this angle means these sides are cut in such a way that the angle set that it will make will always be greater than 24. So it will start to hit every surface possible. It will start to hit every surface possible until and unless it becomes 90 degree to the surface. When it becomes 90 degree, it comes out of the surface. This phenomenon, this coming out of the light, when it is 90 degree, this I will explain a bit later. But always remember, when light is at a 90 degree angle to any surface, it usually comes out of the surface. Okay. So now, as the light happens to spend some time into the diamond, inside the diamond, that is the reason the diamond starts appearing, this diamond glows, it appears shiny. So in your problem, in your gift reasons, whenever you will face the term shiny or glowing, always you should remember that the reason is total internal reflection. And if you see the term silvery appearance, silvery, that means the reason will be critical angle. Understood? So now we have to understand, this last part we have to understand, the critical angle and total internal reflection, on what factors does these two depends. So first let me explain about the critical angle. So on what factors do critical angle depend? So critical angle usually depends on two factors. Two factors it depends. The first is the mu of the medium, the refractive index of the medium. Okay, or you can say the if I don't consider the medium, if I consider the light, then it depends on the lambda or wavelength of the light. How does it depends on the wavelength? More the wavelength, more will be the critical angle. Okay, critical angle is proportional to lambda. मतलब क्या है देखो, say this is the critical angle, say, of violet light. The light have bent 90 degree. Now, if in case of violet light, with the, say this is 30 degree, okay, critical angle. With the same angle, if I incident red light now, I know red light does not get bent as more as violet, okay, because red have a huge wavelength, okay. So it will pass in this way. So in order to bring it more, the critical angle must increase. Understood? So more the value of lambda or wavelength, more will be the critical angle. And next, another factor that it depends on is the temperature. We know more the temperature, the lighter will be the medium, isn't it? It makes the medium lighter. As a result, the light can bend more. Okay, so more the temperature, more will be the angle created. Understood? Now, after critical angle, this is a very easy part. Okay, now next part is your total internal reflection. So, on what factors does this total internal reflection depends? This is very interesting. Now, the first factor is that the light in total internal reflection should always travel from denser to rarer medium. Always remember, उल्टा कभी नहीं हो सकता, रेयर से डेंसर कभी नहीं आ सकता, ये हर समय क्या डेंसर टू रेयर जाना चाहिए. ओके, बिकॉज डेंसर टू रेयर जाने से ही क्या, it will go away from the normal and it will create a refracted angle of 90 degree. Okay, if it goes from rarer to denser, it will never create an angle of 90 degree. It will pass close to the normal itself. Understood? And the two is that the incident angle should be always greater than critical angle. ये वाला तो हमें पता ही है. इंसिडेंट एंगल अगर बड़ा नहीं होगा क्रिटिकल एंगल से, तो कभी भी ये वाला फेनोमेनन टोटल इंटरनल रिफ्लेक्शन कभी भी नहीं हो सकता. Understood these two part? Okay. So after these two part, as we have understood these two part, pause the video, rewind a bit, and see if you have problem in this part or not. Okay. Because now for 2 or 3 minutes, I will be doing some diagrams here. These are the total derivation of this particular total internal reflection. Means actually this total reflection, what does it actually causes in a crystal or in a triangular shaped prism? Okay, what does this particular phenomenon made happen in them? Okay, so before that, please do subscribe the channel, because your subscription, it actually motivates me to make more such videos. Okay, तो अभी जो पार्ट हम करेंगे उसमें क्या होगा उसमें? अरे तुमको नहीं होता. अच्छा चलो मैं ही बता देता हूँ. Here I will be taking certain example of a prism. I will be taking certain example of a prism and show you actually what does this total interreflection do when a light enters in a prism and the angle of incidence is more than critical angle. Okay, what is the phenomenon seen? So let me take an example. If I take an example, it will be better for you. Say a prism have an angle of 90, 45 and 45. Now what is that? Say the triangular face of a prism, say this is the 90 degree, this is 45 and this is also your 45 degree. Now what will appear if a light enters this particular prism? Say in this way. Say there is an object here. And the light is entering in this way, A and B. So what will happen here? So light जब यहाँ पे अंदर आएगा ना, इधर से जब आएगा, देखो इधर पे ये वाला एंगल क्या है, 90 डिग्री है. तो as it enters the particular prism, it will enter straight, isn't it? Because we know whenever a light enters 90 degree, it does not reflect. It goes straight into the surface. Okay, it goes straight into the surface when it enters through the normal. Similarly, this light also, it will enter straight, as it is 90 degree, it will enter straight through the normal. Now, as it strikes the surface, how much angle is created? Can you find that? मिल सकता है क्या वो वाला एंगल? चलिए देखते हैं. ये वाला देखो, ये वाला क्या है, 90 डिग्री. सो ये जो एंगल है ऑब्वियसली 90 होना चाहिए, सप्लीमेंट्री एंगल्स. ये वाला 45 है, तो ये वाला हम अब निकालेंगे एंगल सम प्रॉपर्टी से. तो क्या आएगा इसमें? 180 minus 45 plus 90. The answer, I think it will be 45 degrees, isn't it? So if this is 45, this is the normal. So the whole angle should be 90 ना. So ये पार्ट कितना आएगा? ये वाला 45 होने से ये वाला पार्ट होल 90 करने के लिए ये वाला भी 45 ही होगा. और ग्लास के लिए जो क्रिटिकल एंगल है, वो वाला ग्लास के लिए क्रिटिकल एंगल है 42 डिग्री. सो देखो ये वाला जो एंगल है ऑब्वियसली इट इज ग्रेटर देन क्रिटिकल एंगल ना. सो लाइट क्या होगा, इसमें बाहर नहीं निकलेगा, ये वाला अंदर ही रह जाएगा. और जाएगा कैसे? ये वाला 45 होने से ये जो रिफ्लेक्टेड एंगल और रिफ्लेक्शन एंगल यहाँ पर बोलते हैं, ये वाला भी कितना होगा? 45 ही होगा. ये एक तरह का रिफ्लेक्शन ही है, बट रिफ्लेक्शन के द्वारा हो रहा है. ठीक है, तो इधर पे भी इट विल बी 45 एंड द रिफ्लेक्टेड एंगल विल आल्सो बी 45. नाउ यू सी दिस होल एंगल इज ऑन 90 ना. 45 and 45 makes 90. So here you see it will also be 90 because it is a what? It is a alternate angle. See this particular line, if I draw here, if this is 90, this will also be 90, alternate angle. Parallel lines, alternate angles. Okay. So 90 होने से तो निकल जाएगा यहाँ से. So ये जो लाइट है AP, ये कैसे कैसे दिखाई देगा यहाँ पे? ऐसी तरह. Okay. So इसको बोलते हैं 90 degree deviating prism. Okay. Now next case, अगर ऐसा नहीं होते, देखो बहुत सारा केस हो जाएगा यहाँ पे. अगर लाइट इधर से ना आके अगर इधर से आ जाए तो फिर क्या होगा? देख लो. तो इधर से अगर आ गया, ये वाला है 45, ये वाला 90, इधर पे है 45, तो फिर क्या होगा? देखो दिस लाइट इट इज ऑब्वियसली 90. ओके, मैंने इंसिडेंटली ऐसे किया कि वो 90 हो जाए, तो इजी होगा वो वाला डायग्राम. ठीक है, तो ये पूरा अंदर आएगा, यहाँ पे नॉर्मल होगा. अगर तुम निकालोगे वो वाला 45 डिग्री होगा. सो यहां से ये वाला भी 45 से जाएगा, 45 से जाएगा. इधर पे और एक नॉर्मल आएगा ना, सरफेस का नॉर्मल सरफेस है 90 डिग्री. इधर पे कौन सा वाला एंगल होगा? निकाल के देखो, ये वाला भी 45 ही होगा. एक शॉर्टकट बताता हूं. अच्छा अभी नहीं बताऊंगा, लास्ट में बताऊंगा. अभी बताने से इतना ध्यान नहीं दोगे. ठीक है. अच्छा, तो नाउ हियर यू सी इट विल आल्सो बी 45. ओके, इधर से और क्या, फिर से 45 से ही जाएगा. ओके, इधर जब आएगा ये वाला हो गया 90. निकाल के देखो ना, इधर पे ये 45 है, ये 45, तो ये भी 45 हो गया हमारा. तो 45 ये वाला ऑब्वियसली 90 और सप्लीमेंट्री एंगल्स ये वाला 90 निकलना है. अंडरस्टूड? ये वाला 90 निकलना है. 90 आने से तो पूरा ये बाहर चला जाएगा. तो इफ दिस इज AB, if the object is say AB, so B's light came here, here and here. This is your B and this is your A. So you will see that the object is totally inverted now. Okay, the light as it enters, as it goes outside the prism, the object is totally inverted. Okay, this type of prism is known as erecting prism. Okay, because this type of prism, what is that? It actually inverts or erects a particular image. Okay, now और भी केस हो सकता है. देख लो, देखने में क्या आ जाता है. चलो और एक केस देखते हैं. से I have kept the prism in this way. So this is your 90, your 45 and this is your 45. तो this is the third case. अच्छी तरह मार्क कर लेना डायग्राम. ठीक है, ये वाला एग्जाम के लिए बहुत जरूरी है ये तीनों डायग्राम. ठीक है, और भी आएंगे, but these three are very important for your board exams. Okay, now if a light strikes the surface in this way, here this is special because you will see that the incident angle is not 90 degree. This is a bit curved, isn't it? So the 90 degree of this surface will be like this. So this is the light, actually it is not 90 degree, it is actually making some angle here. Understood? That means whenever it enters the prism, it will be diverted a bit. Sorry. It will be diverted a bit. ये वाला आकर गिर गया यहाँ पे, तो यहाँ पे कितना वाला एंगल होगा? It is seen that it is approximately about 45 only because it is striking. Here is the shortcut I am telling him now. बताना ही पड़ेगा. Shortcut is whenever light enters and strikes a surface, the angle close to it, it actually strikes the surface with that angle only. जैसे यहाँ पर है 45 डिग्री, तो लगभग यहाँ पे हमेशा 45 के करीब ही आएगा. जहाँ पर स्ट्राइक करोगे, कैलकुलेशन भी किया तो ये 45 के करीब ही निकलेगा. ठीक है, तो इधर से ये चला जाएगा और इधर से ये वाला चला जाएगा 45 करके ही चला जाएगा. इधर जाके फिर से नॉर्मल होगा और ये बाहर निकलने से सीधा नहीं जाएगा, क्या अवे फ्रॉम नॉर्मल मूव करेगा. दैट मीन्स ये वाला अगर ए बी हो गया, तुम देख लो ए का लाइट आके नीचे चला गया और बी का आ गया ऊपर में. ये भी क्या इरेक्टिंग प्रिज्म की तरह ही काम करता है. अंडरस्टूड? नाउ अबाउट द नेक्स्ट केस. फिर नेक्स्ट में मैंने एंगल कर दिया चेंज, ये वाला है 90, 60 एंड योर 30 डिग्री. So I've taken this case 90, 60 and 30. So this is an not iso, it is an what? Scalene prism. Okay, सब एंगल डिफरेंट, तो स्केलिन प्रिज्म हो गया इसका. ओके, तो इसमें कैसे आएगा डायग्राम, चलो देखते हैं. तो अगर मैंने ऐसा वाला ले लिया प्रिज्म, ये वाला 90 है, ये वाला समझ लो 60 है, और ये वाला समझ लो 30, तो डायग्राम कैसा आएगा देखो. तो अभी मैं क्या करता हूं, यहाँ पे लाइट, say I have selected only one light only. Okay, it will be easier now if I select one light. So here it is on 90 degree ना, समझने में इजी होगा. ओके, दो लाइट लेने से थोड़ा दिक्कत हो जाता है जल्दी जल्दी समझने में. ओके, आई वांट टू मेक द वीडियो शॉर्टर एज पॉसिबल. ओके, फॉर यू. तो ये लाइट एज इट इज 90 डिग्री इट विल एंटर स्ट्रेट. हियर देयर विल बी द नॉर्मल. ये वाला 60 हो गया, ये वाला 90 हो गया, ये वाला हो जाएगा 30, और 90 से ये वाला हो जाएगा 60. इजंट इट? मैंने बोला ना, जिसके सामने हो वही होगा उसमें. तो 60 अगर हो गया, फिर से यहाँ पर 60 आएगा, तो ये वाला 90 से हिट नहीं करेगा, ये वाला पूरा 120 है, पूरा 120 है. ओके, सो यहाँ पर अगर नॉर्मल मैंने ड्रॉ कर दिया यहाँ पे, तो कितना एंगल आएगा यहाँ पे. ये वाला देखो 30 के करीब गिरा है ना, लगभग 30 के करीब ही आएगा ये वाला एंगल, लगभग आएगा 30 के करीब. तो ऑब्वियसली ये जो प्रिज्म है, द क्रिटिकल एंगल ऑफ दिस प्रिज्म इज 42 डिग्री. ग्लास का क्रिटिकल एंगल है 42 डिग्री, ये 42 से कम है, इजंट इट? सो यहाँ पे रिफ्लेक्शन नहीं होगा, टोटल इंटरफ्लेक्शन नहीं होगा, यहाँ पे लाइट निकल जाएगा. और कितने में निकलेगा? मोर देन 30 डिग्री में, क्योंकि ये लगभग 30 के करीब आएगा, लगभग 30 के करीब. तो ये वाला ज्यादा होना ही है, क्योंकि ये अवे फ्रॉम द नॉर्मल जा रहा है. ठीक है, अगर मैंने ये वाला डायग्राम को थोड़ा सा चेंज कर दिया, तब क्या होगा? जैसे कि देख लो, जैसे यहां पर हो गया 90, और यहाँ पे कौन सा वाला दिया था पहले? 30 नहीं 60 दिया था ना, 60, और यहाँ पर हो गया 30. अभी मैंने समझ लो यहां से लाइट को एंटर किया, पहले इधर से किया था, अभी इधर से कर रहा हूं. ठीक है, स्ट्रेट लाइन. मेरा स्ट्रेट लाइन भी इतना टेढ़ा होता है ना, देखो. सो ये पर्टिकुलर लाइट कहा जाएगा. सो एज इट इज 90, इट विल एंटर द पर्टिकुलर प्रिज्म स्ट्रेट एंड इट विल हिट दिस सरफेस, इजंट इट? सो कितना आएगा एंगल? 30 हो गया, ये 90 हो गया, ये 60 हो गया, ये हो जाएगा 30. और 30 होने से तो ये क्या लेस देन 42 है, इजंट इट? तो लेस देन 42 होने से यहाँ पर नहीं आएगा, ये रिफ्लेक्ट नहीं होगा, ये रिफ्लेक्ट हो जाएगा बाहर की तरफ. तो ये मोर देन 30 डिग्री हो जाएगा. तो ऐसे करके हम क्या कर सकते हैं, अगर हमको ये वाला टोटल इंटरनल रिफ्लेक्शन एंड क्रिटिकल एंगल, ये दो चीज अगर हमें पता हो ना, किस मीडियम का क्रिटिकल एंगल कितना है, किस मीडियम का टोटल रिफ्लेक्शन कब हो जाता है, वो वाला पता होने से हम क्या कर सकते हैं, इसमें ऐसा वाला बहुत सारे एटिरेशन कर सकते हैं. हम जान सकते हैं प्रिज्म में कैसे लाइट भेजने से कैसा वाला आउटपुट आएगा तुम्हारा. उससे हमें बहुत सारे चीज ऑप्टिकल इंस्ट्रूमेंट बनाने में बहुत मदद मिलता है, ये वाला टोटल इंटरनल रिफ्लेक्शन से. Understood? So I'll be giving you a homework here about this particular diagram. So I'll be stating you some homeworks in the comments below. So comment करना, comment करके मुझको बताना डायग्राम आपको कैसा मिला. ओके, कमेंट्स में हम मुझको बताना, मतलब किस तरीके से लाइट निकला है, लाइट एक्चुअली क्या किस एंगल से निकला है, वो मुझे जानना है, आप कितना समझ रहे हो. ठीक है, और एक चीज, ये जो क्लास है उसके बाद हम लोग क्या करेंगे, एक्चुअली हम इसमें कॉन्वेक्स और कॉन्केव मिरर, सॉरी नॉट मिरर, लेंस के बारे में नेक्स्ट क्लास में पढ़ेंगे. टिल देन स्टे सेफ, स्टडी हार्ड एंड watch the video. If you like the video, share it as much as possible. Okay, thank you.